Hi there. Today we are going to look at data types and variables. So, what are variables? Variables, right? Variables and data types. So, what are variables? Variables are nothing else but they are data carriers. Data carriers means they carry data. They carry data. They can store data, transfer data, or transform data, right? So, these are variables, and each variable has a specific data type, and these data types can be inbuilt or custom data types, right? So what are data types? That, like, what kind of information we are going to store? That's the information it provides. What kind of information is going to be stored? That's what data types provide. Now, talking about data types, there are two different types of data. One is primitive data types and non-primitive data types. So in primitive data types, again, we have further categories, like, let's say we want to store numbers, we want to store characters, store characters, or stream of characters, stream of or sequence of characters, right? So to store numbers, there are multiple options, right? So one is with, sorry, without decimal, and the other option is with decimal. So without decimal, if you have heard about any programming language, you will quickly say there is an integer data type, right? So int. So before we go there, let's understand the syntax of variables. So for any variable, the simple syntax is, even primitive or non-primitive, the simple syntax is, let me write it here. There are two aspects. One is variables and the other is data types, right? So syntax, if we talk about syntax, the syntax is simple. First we write the data type, then the variable name, right? And each statement in Java ends with a semicolon. So this is called declaring a variable, right? Announcing that, hey, I am creating a variable named this, which has a data type this, right? So declaring a variable. We can also assign values, right? Assign values to a variable. And how do we do that? Variable name equal to the value. This is called assignment. And as I mentioned, each statement ends with a semicolon. So this is called assigning a value. And here equal to sign, here this equal to sign is an assignment operator. Equal sign is an assignment operator. You can also write both these statements in one line. Data type space variable name equal to value semicolon. So this is declaration and initialization both together, right? So you can do it that way as well. So if I want to create a numeric variable, so integer, that is a inbuilt data type, and then a variable, let's say I var1 semicolon. So this I var1 is, it's not a keyword, it's a custom data type where I mean it's a naming convention just to represent that I stands for integer. So this particular variable is going to carry integer values, right? So you can assign it later on. I var 1 is equal to 10. Or you want to do it in the same line as we mentioned here. So integer I var 2 is equal to 10. Right, so this would be our declaration and this would be our initialization or assignment of value to a variable, and here it would be declaration and initialization altogether. Right, now how do I check whether the values are assigned properly or not? So Java gives us a very straightforward way to display these values over a console. So console is nothing else but our, let's say, our monitor, right? The output, where we see the output, and that's our console. Our computer is a console, right? So on the monitor, if you want to see, so even Eclipse has its own console where it will display the output. So if you want to look at the output of this particular value or this particular value, you can do that as well. So let's start with a simple message, right? So right at the start, I'm going to give a simple message, and to do that, we'll write system dot out dot print ln, that is print a line. And if I don't write anything here, it will be a blank string that will be displayed on the console. So nothing will be visible. But if you want to give a message, you can write that message in double quotes. So let's write this session is about variables and data types. And right now we are talking about primitive data types. So system dot out dot println, and here also you can write, I'll write primitive data types. And if I want to display the value here, now this was a static string, a message, but if I want to display the value here, I can also do that. System dot out dot println, and you can just give I var 1 semicolon, save, and from your package or project explorer, you can just go here and right click from here on the file which you want to execute. You can just execute your code, and once that executes, your console window will be open. See, console window is on, and then you'll see the messages first and then the value 10. See the value 10. You can also change the value from here. Let's say I'll make it 50. And then now if you don't want to do it from here, the other way around is, I mean, if you don't want to execute it from here, right, the other way around is this button, run button. You can just click here and it will execute the program for you. See, value 50. Similarly, I var 2, you can write the same statement here. System dot out dot println, and here you can write I var 2, and if you execute, you will see the value 10 here. So you'll also see 50 and 10, both values, right? So this is integer data type. But as I mentioned, to store numbers without decimal, there are 4 different types of variables or 4 different data types that you can create. The first one is integer that we already saw. The other one is byte. B var 3 or B var 1 is equal to, let's say, 10. Okay, even this you can write in there is a code snippet. So if you don't want to type each and every word, you can just write the shorter way of doing it. So sys, that is sys out, and then control space bar, and it will display this entire message for you, that is the entire syntax for you. And here you can just write b where 1. So now if I execute this, I should be getting 50, 10 and 10 again, right? So let's write a proper message here, primitive data types and integer. So similarly here primitive data type, and we are talking about byte, right? So this is primitive data type integer, primitive data type byte. There is another uh, non-decimal, or an integer type variable, which is also called short. S where 1 is equal to, I'm giving the same value and then I'll tell you the difference between them. So sys out S where 1, and here I am going to write copy, and here I am going to write short, save it and execute. See, then I'm going to write the last one for integer. Let me write long L where 1 is equal to same value 10, system dot out dot println L where 1, and let's display the message also here, long. And if I execute, same values, same values. So why do we have these four data types for the same kind of or same value? It's not the same. I'll show you the difference now. Now let's consider you have you have this size of paper. This is the document that you have. So, and this document you want to courier somewhere, right? This document you want to courier somewhere. So what you will do is you will pick a cover of this size. I can also fit the same document in a cover of this size. I can also fit the same document in a cover of this size. The same document can fit in a cover of this size. So what if I just copy this cover from here and paste it? See, it fits in very nicely. It fits in very nicely. But how about your, consider this as your memory, your memory, your computer memory, not your memory, your computer memory. What would happen if you have 50 different variables which are going to hold this kind of smaller data? Is it not advisable to use this sort of envelope to store that data? So based on what kind of data, what I would say size of data you are going to store, based on that you should be picking your appropriate data type. So consider that this is your byte data type. This is your short data type. This as your integer data type, and this as your long data type. How do they differ? They differ with the minimum and maximum values difference, and also based on the memory allocation, the how much memory it is allowing you to store, right? So these things are predefined. The number range is predefined. For example, for byte, the minimum value that it can store is 128. So from minus 128 to 127 is what a byte can store. Let's take a look. So in the code, what I'm going to do is byte. I'm going to write 127. And now if I execute, 127 is there. But as soon as I write 128, see what happens. I'll hover it here and see what is the message we are getting. Type mismatch cannot convert from integer to byte. So it is assuming that is this is beyond the limits of a byte data type. You need a bigger envelope, a bigger cover here. So if the number goes beyond 127, even negative, let's try that out. Let's say this is minus 128. No errors. Why? Because that's the limit. But if you write minus 129, it will immediately give me a message. Right? So all these different data types, primitive data types, have a specific memory allocation. It also has the kind of, the range of numbers that it can store. For example, let's consider, we have seen byte, let's consider short now. So in short, you have the range is minus 32768 to 32767. That's the range for short. Let's try it out. Short. So if I write 32767, no problems. Let me change this error first. Let me remove this error and 7. This is fine. So 32767. That's the boundary line here. Now what happens if I make it 8? See the same error here. It does not fit in short. It is asking us to store this in integer data type. In the integer data type. That's a big size envelope. This big size envelope. Right? So even integer has its own limitation. I mean from minus some value to plus some value. Long also has from minus some value to plus some value. Right? So for these primitive data types, there is a range that is specified, and based so if you are aware that this particular variable, instead of creating integer, if you know that this particular variable is going to have the values within a typical range, you should be selecting an appropriate data type there. Right? Picking an appropriate data type is very important. That will save a lot of memory for you, and the code that you create will be very much optimal. Right? So that's about the numeric data type. Now let's focus on the numbers with decimal. Stores numbers, and A, this was without decimal, and now B with decimal. So let me write it. Let me write a message here. My console window should have proper messages. Sys out, and I'm going to write numbers without decimal. Now we have sys out numbers with decimal. So there are two different data types which you can use for numbers with decimals. One is float, f, where 1 is equal to, I can write 10, no harm. But if I write system dot out dot println, and if I write f where 1, let's see what happens. The value is 10. Let's see what happens here. See, on the console window it displays 10.0, right, because it is a float data type. So automatically it will take that decimal value. If I have not mentioned even though it picks the dot 0 on its own, right? That's how a float variable is. And the other one is double, d where 1 again 10, and system dot out dot println, and again here d where 1. I'll just write the messages here, sys out decimal values, sorry, float variable, decimal is already there, float variable, and here we write double variable, and let's see what the output is. See, 10.0, right? So this is how you use float and double, right? Float and double. But how about a numeric value? I mean a decimal value, actual decimal value. So let me write f where 1 is equal to 10.5 semicolon. What happens here? Similarly, see, I'm getting an error here. Let's see what that error is. And here I'm going to write d where 1 is equal to 10.5 semicolon. Now here I'm not getting an error, but here I'm getting an error. So if I'm just writing, so for float, if I'm just writing this, I need to specify f here, f. I need to specify, sorry, lowercase f here, which means I'm trying to, I'm giving a message that this is a float data type. And now if I display this message, right? Yeah, so this was before, this is after. So now if I execute 10.0, 10.5, 10.0, 10.5. And again, the basic difference between these two is the envelope size, right? This has its own, the range and memory allocation accordingly. So you can pick an appropriate one. This is a small cover and this is a bigger cover. Okay, so this is about storing the numeric values with decimal and without decimal. Okay, now apart from the numeric data types, there are some non-numeric data types as well. For example, if you want to store information in yes or no, that is true or false. So at times you might want to take a decision based on true or false. So you might want to set up a flag, right? You want to create a variable which you can use as a flag, whether the flag is up or down, whether the variable is set to yes or no, that is true or false, and that data type is called boolean, right? So boolean, let's say bln where 1 is equal to, you can write true, or bln where 1 is equal to false, right? And if you display it on the console, bln where 1, it will also display that value as well as false, right? So that's a boolean value. In the upcoming sessions, when we will look at conditions and loops and all, we'll be using a lot of boolean variables just to set up a flag whether the loop needs to be broken or not, whether the condition needs to be, whether a condition is proper or not. So yeah, this is one of the very important data types that is widely used, right? So stores information in yes or no. Then you also have variables which stores characters, right? So this is a string, right? But we have characters. So char, ch for example, and you store it using single quotes, a semicolon, right? Similarly, let's say So if I display it on console, sys out, and if I write ch, it will display the value a. See? So similarly, let's say b, and if I execute, so it will display b. So whatever you write here, but a single character. If you write a space, right, a space won't be visible, but it is there. If I select this, see it's there, right? Similarly, but what if I write AB? It will shout. See, invalid character constant, which means I am writing two characters here. So a character has to be a single character, right? A single character only. That's a char string. I mean char data type. And then last but not the least is one of the non-primitive data types, which is a string, right? So string str1 is equal to, in double quotes we write, if we want to initialize, we initialize in double quotes. So I can write hello world, and this also you can sys out, you can write str1, and if I execute hello world. So why do we call it, I mean, why is this different from these other data types? Because there is a predefined size, memory allocation, I mean how much memory these guys are going to use, it's already defined. But in a string we don't know, it's endless, it's a series of characters. This is a character, right? So character, it we know how much space it is going to store, it is already defined there, right? So for character it's 2 bytes, 2 bytes. But for a series of characters, these are series of sequence of or series of characters, and this is going to be endless. So we don't know how much width, I mean how many characters we are going to store in this variable, right? And that is why there is no predefined memory allocation, right? That this particular variable is going to have, store use this much of memory. There is nothing defined for that, right? That's one of the important differences between a string and all the other data types. There are a lot of other non-primitive data types as well, but string is a commonly used one. So string can be, you can term string as a character sequence. It's a character sequence. It is a character sequence, right? It's a sequence of characters. This R, so you can write an R here, but these are individual characters and this is just one characters, right? So these are the widely used data types and their, their syntaxes, right? So this part is important, this part is important here, right? Understanding what kind of data type you should be using based on what type of or what range of data it is going to return. You can pick an appropriate data type for that particular variable. And one of the very important aspects is, and something that I keep telling everyone, that variables, use variables only if you are going to use the value that will be assigned to it more than once. If there's a value that you are going to assign to this particular variable, any variable that you write, for example this, if this value is coming from somewhere, right? It's not a hard code value. For example, in future we'll see that the values are coming from a function, right? So if you are not going to use this variable more than once, if you're going to use it more than only once, don't store it in a variable unnecessarily. Don't use the memory. You can directly use it wherever it is needed, right? So use the variables only if you are going to use the variable more than once, if you are going to use the value more than once, right? So that's all about data types, I mean variables and their data types. Hope you have enjoyed the session. Thank you. Happy learning.